more difficult than derivatives, but derivatives are easy because definition it's difficult. So
What are you saying?
Definition.
Okay.
Yeah. No. I don't think so. Derivatives are like relatively easy, right?
Okay, we're gonna come back to this question, Xavier. Shh. We're gonna come back to this question. We're gonna talk about one more thing. It's called summation, and why it's summation. So this part you might need to take notes because this part is something you never learned last year. I didn't teach you just because I don't think you guys are ready for it that year. So this year I'm gonna say you guys are ready for it. So Derek, I cannot talk over you. Gotcha.
Full screen.
Yeah, full screen.
Yeah.
Make it big. Okay.
What? I'm not gonna hit you.
Okay, so we're gonna start with this question. This question, Frederick Gauss. Do you guys know who Frederick Gauss is?
He's the mathematician.
Very good. But he's also a physicist. He's also a physicist. He's a so if you guys learning about electro physics, AP physics, you should learn something called Gauss's law.
Yeah. Gauss's law.
Yeah, Gauss's law is like how big the wire can conduct how much electricity or something like that. It's depending on how the diameter of the wire. So Patrick Gauss was 7 years old, and he's very annoying, like kind of like Andrew, yeah. And so he'll keep on harass the teacher, and the teacher's like, okay, leave me alone. And the teacher's like, okay. So he's like, well, give me something to do, I'll leave you alone. And the teacher, at 7 years old, right? The teacher says, hey, add up all the number from 1 plus 2 plus 3 plus 4 all the way to 100. And the kid come back and like, yeah. So the kid come back in 2 minutes, and he got an answer. And his teacher did not believe him. He got an answer. So I don't know if you remember, how did he got this number? I don't remember. How about everybody else? How did he add 1 plus 2 plus 3 plus 4 all the way to 100, and he did it in 2 minutes?
He did like first number plus last number. There was something.
You're right. You're right. Good. So just like Xavier will say, Xavier says something to do with first number. So 2 plus 3 plus 4, right? And the plus 96 dot 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 plus 97 plus 98 plus 99 plus 100. So the first number plus the last number is equal to 101. 99 plus second is 101. 98 plus 3 is equal to 101. So eventually it's going to be 50 plus 51. Or the other way around. It's equal to 101.
It's 50 times 100.
Yeah, so it's 51 plus 50. So there's going to be 101 times 50. So it's equal to 50, 50.
That's what I was gonna do.
So, yeah, so sometimes annoying kids are pretty smart. So, like what I said about Andrew.
You're not, I don't say you are pretty smart.
Well, it is what it is, right? It's okay. You gotta be proud of what you are. So you guys don't know what a sigma notation is. This is called a sigma notation.
That means chat as well.
I equal to 1 and that's 6. Okay? Derek, Robert, make sure you write down notes.
I is in like square root of 1.
I.
Square root of negative 1. Or is it a different thing?
So I'm gonna just tell you, follow. So this is called a sigma notation. You're gonna see a lot in calculus too, but this is a start with a sigma notation. A sigma notation start with this is called lower bound. So this lower bound is a number to start. So number to begin. Okay, and this is the upper bound. So upper bound. So basically, what you're doing is you're gonna plug in all the whole numbers into I, and you're gonna sum it all up all the way to 6. Does that make sense?
Mm-hmm.
Yeah.
So it'd be 1 plus 2 plus 3 plus 4 plus 5 plus 6. Why they start at 1? Can they start at 2? Yes.
Yeah.
Can they start at 3? Yes.
Yes.
Can they end at 10? Absolutely. So that's going to give you, I think that's going to give you 6 plus 6 is 12. 12 plus 9 is 21. So that's 21. Now, sometimes you can have different question like this. I equal to 2. And let's say, I'm not going to do too big of numbers. Let's say 6. Have 3i minus 2. What does this mean? The I is like a,
Imaginary.
no, in this case, I is not imaginary. That's actually very good confusion because I is not imaginary in this case. I is some type of, huh?
Complex.
No. I is some type of number that listing from 1 to 6, but has to be a whole number. Cannot be 1.5, cannot be 1.7. It's just 1, 2, 3. It's like a listing. Like computer language, computer software, you can actually just do listing all the numbers and it'll list all the whole numbers for you between what number to what number. Basically, you plug in and you're gonna add all of them. So what happened is this one is gonna be, it's gonna be 6 minus 2, right?
Yeah.
Because 3 times 2 minus 2
That seems legit.
and plus 3 times 3 minus 2 plus, because I plug in 3, 3 times 4 minus 2 plus 3 times 5 minus 2 plus 3, 5 minus 2. So basically just adding, plug in a number in there and produce the sum. Sum is adding up all the number once you plug in 2 all the way to 6. So in this case, they will get 6 minus 2 is 4 plus
Is that logical?
7 plus 10 plus 13 plus what?
6.
Those 6, this is 6, right? So it's gonna be
16.
16.
Mm-hmm.
And
We're all like that.
so this 2 is 20, 30, 40, 50. I think it's 50.
That's what I said.
That's 50.
Wouldn't it be easier to just like if you know 2 to 6 is 5 numbers, you can multiply 5 times -2, and then you could do the like value between 2 to 6, which would have been 20, and multiply that times 3, and so it would be 60 minus 10, which would be 50.
Yeah, whatever, long as it work, it's fine.
Okay.
It's okay. So the summation is a notation for you to add up all the terms. Add up all the terms. So depend on how many terms they have. Now some people says, can I start with 0? Yes. Can I start with negative number? Yes. Can the upper bound to be negative number? Yes, because you can end at a negative number. But it's no way that you have, say, let's say -2 and end up at -5. That just doesn't make sense. But you can have start at -2, end up at 0.
So the upper bound can't be lower than the lower bound.
Exactly.
Can't be.
You have to move right.
Yeah. So it's kind of like a intuitive, but it's, and some people says, hey, can other way be performing different way? Yeah, you can have summation like this of j. I don't have to start with I is equal to 1 and 5, 1 over square root of j. And that just means 1 over square root of 1 plus 1 over square root of 2 plus 1 over square root of 3 plus 1 over root of 4 plus 1 over root of 5, and you stop right there. And you stop right there. So this is not the hard part. The hard part is going to come up in a second. So let's talk about a couple properties. This simple property is going to save your butt, which is, this property is very intuitive. I equal to 1 of n of a constant of the term. So what happened is, the term can be factored out. I equal to 1 n of a to the term. So in this case, ai is the term. Sorry, ai is a term. From the prior case is 1 over square root of j. That is the term. Also something else, it can kind of like have a distributed property, but it's not distributed property, it's just a property of summation. I equal to 1 to the n of ai, which is some type of term,
This is A times I.
part of mass bi. So that's going to be summation of I equal to 1 of n ai plus summation of I equal to 1 of n of bi. So they're very intuitive. They're like kind of distributed property.
Is this A sub I or A times I?
A sub I.
Simplifying the expression.
Yeah, we're going to simplify the expression in a second, but we're going to give you some summation formula. And this summation formula, for the first time, I'm going to tell you, you don't need to memorize it. Because I will give it to you, or the test will give it to you. Because normally, no student ever memorizes this formula. Now, for me, probably the I1, I remember. So this is the first formula. Very easy. It's equal to C equal to Cn. Second one is a summation of I equal to 1 of n of I. That's going to give you n times n plus 1 over 2. Think about Federic-Gauss used this. It says 100 term times 100 plus 1 divided by 2. So that's 50. And that's equal to 50 times 101. And that's equal to 50, 50. And that's what Federic-Gauss used. He come up with this equation at 7 years old. Yeah. And he come up with this equation at 7 years old. He said this can add up all the number.
Is this his law?
No, it's not good. His law. He just discovered it. But he didn't like put a stamp on it, but he discovered it. So, I mean, at least people give him credit for it. Now, sometimes you don't have just I. You might have I squared. So you're going to have I equal to 1 n of I squared. It's going to give you an equation of n times n plus 1 times 2n plus 1. Now, again, this is just an equation. This means if you have I squared term, let's say if I have something like I squared of 1 to 5, then all you gotta do is plug in 5. 5 times 5 plus 1 times 10 plus 1 divided by 6. And that's gonna be 6 cancel out. It's gonna be 5 times 11. So it's gonna be 55.
Wow, like specifically over 6?
If you don't believe me, you can add up all the number. 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared. 1 plus 4 plus 9 plus 16 plus 25. This is 20. This 30. 30 plus 25 is a 55. So the equation works. Pretty crazy, right?
Yeah.
So all you gotta do is plug in an equation. If you have I squared, equations work. Third equation, again, you don't need to memorize. I will give it to you if it's your exam.
Oh, well, can you explain number 2 again? Where, like, is that value of I, is that supposed to be like, oh,
You got it?
Yeah.
Are you sure?
yeah.
Okay. So this is the last one. You got I cubed, I squared, I, and the C.
number one is if it's a constant, then the answer would be constant times n.
Mm-hmm. So if you have, let's say, summation of 3, I equal to 1, and let's say 4, that just means 3 plus 3 plus 3 plus 3, because there's nothing to plug in. So it's just going to add up whatever it's giving.
Oh, okay.
So it's going to be 3 times 4, right? So it'll be 3n, so it'll be 12.
Can you go up for a second?
Now I'm going to show you the couple property at work. So remember, we can have a summation, and we can have I equal to 1, and we can have n, and then we got I plus 1 over n squared. And we can say, hey, evaluate n equal to 10 or 100 or 1,000, right? And then you say, well, how do I do this? Now, one nice thing is this property here. Do you see this property that k can be outside? Long as not anything deal with I, you can take it outside. Xavier, put your phone away. So that n can be outside, so it'll be 1 over n squared, summation of I equal to 1 of n of I plus 1. Do you remember this constant? Right, this constant is basically like some people call it.
Planck's constant.
You just come up with random stuff.
Planck
Do you,
constants are
do you
real-
know what the Planck constant is?
6.626.
And to the negative 32nd? Or is that Avogadro's?
That's Avogadro's.
It's chemistry.
6.23 times 10 to 23rd is. No, that's Avogadro's number.
Oh yeah.
Planck's constant is negative 18, right? I don't know. 6 point something. I don't know.
No,
Look up. I'm interested now. Planck's constant.
Imagine.
6.6260701.
I think
Oh,
it's 34.
close.
That was
I'm
wrong.
calling it now. The number 2 is Andrew's constant.
Set me up for that.
Who?
Susie Boo.
Who's Susie Poo?
Oh my gosh.
Is that your girlfriend?
No. Stranger Things.
Yeah, I thought about that when he said lecture.
Like,
I was like,
Who's Susie?
Most
Main
Stranger
character.
Things.
we did not need to have like a whole
I've watched Stranger Things, and I
anything
still love
at
it.
Tom.
Okay, so remember this also have a distributed property, so that's going to be 1 over n squared times summation of I equal to 1 of n of I plus summation of I equal to 1 to the I to the 1. And this one has a equation, n times m plus 1 over 2, right?
Mhm.
And the other one is, I believe, is Cn, n times 1, so it'll be plus n. So what's nice thing is, you can multiply this by 2 over 2, just do some algebra stuff. So it'll be 2 of n squared plus n plus 2n. 1 over n squared. So I just distribute that. 1 over n squared times n times m plus 3, I believe, over 2. So n,
Why is it times 2 over 2? So just so you can combine the numerator?
yeah. So that will end up to be m plus 3 over 2n. So I can evaluate by plugging 10 or 100 or 1,000 just from here. So which is nice. You don't have to do it individually. You can just plug in at over there. That's going to be the sum of that. We do get all of them because we did some of them.
We get all.
He got it right.
You just made the thing go back.
Oh.
I just repeated backwards. Okay, so let's talk about your bill work, which is the first time this year I give you bill work.
Snacking.
That's so weird.
What is a bill work?
Touching your
No,
ruler.
No. Okay, so bill work you got 15/4, I think. That's your answer, right? And or 3.75. 3.75 is the answer. And let's talk about bill work. And bill work is basically f of x equal to x squared between 0 to 2. And I use the rectangle. And I will 4 equal subinterval, right? 4 equal subinterval. And I love the way actually Robert did that one. It's actually pretty cool. He put a 0.5 in the front, which is the width. Okay. So basically, I'm going to show you slow motion though. I'm going to talk about the width. What's the width of each rectangle here? Or 1/2, right? So, and he factored outside, but I'm not going to factor outside. I'm going to say f of 0.5 because I'm going to plug in 0.5 to get the y value plus f of 1 times 1/2 plus f of 1.5 times 1/2 and the plus f of 2 times 1/2. And I think that's what you guys did because if you plug in 0.5 here, if I plug in 0.5, it will be 0.25, right? Or 1/2. Sorry, what? So be it'll be 1/8, right? It'll be 1/8 plus 1/2 plus 3/2 is what?
3/2.
3/2, but it's 9/4 times 1/2, right?
9/4.
Because I gotta plug in square.
Oh, true.
Nice. You feel like an sanitizer.
Right? Plus, which one? 4 times 1/2? So it's 2?
Yeah.
But I'm going to write down 1/2. So that way is, this one's 1. And this one is, sorry, let me write down, it's 1/2 to the square times 1/2. So that's equal to 1/8 plus 1/2 plus 4/8 plus, wait, 9/8. 9/8 plus 4/2, right?
Yes.
So eventually that's gonna be 10/8, which is 5/4, plus 2.25.
What are you
Why don't we
doing?
make decimals?
Stop doing decimals and shit.
Going back and
2.5, sorry, it's 2.5.
Go back to fractions, man.
Okay, 5/2, sorry. And I multiply 2/2, so it'll be 10. So it'll be 15/4.
What do you say? 5/2? Oh, I see.
So the final answer is 15/2. 15/4. Now,
Should now be back to A1.
this part is a part that Robert and Derek didn't pay attention because this part is going to be completely new. Is I'm going to show you what is the definition of integral. Definition of integral is going to be given at a certain way. So it's going to be limits of n approach to infinite
What the heck?
of summation
Everything under the curve.
I equal to 1 to the n of f of mi, which is the right endpoint, times delta x.
And I is the right endpoint? In this case, or like in
This one is going to be right endpoint. It's a small m. But mi is easier because right endpoint, you go with the right endpoint. In this case, it will be 2, 3/2, 1, and 1/2, right? So it's a very easy value. So for me, like this is such a hard thing to memorize, but it's not. So basically, this here represents the height.
Is it MI?
Yeah, this represents the height of each rectangle.
Oh, change the way.
And change of x is the width. You guys are genius.
And then it's just a rectangle.
And then you'd add it up. If I break to infinite amount of pieces, you add them up infinite amount of pieces.
The area under the curve.
Will be the integral between the functions, right? So it'll be integral between a to b. Okay, so then we're gonna say, hey, how do I define the width? The width is gonna be b minus a over n. Why? Imagine that we have f of x is equal to x squared, and between 0 to 2, each width is what? Is 2 minus 0 over n. Would you say it's 2 over n? So if I break 2 rectangle, then it's 2 over 2. If I broke to 4 rectangle, it's 2 over 4. Derek, are you okay?
Yes. I was just thinking.
I thought it was like a chessboard on top,
No, I was thinking about.
like Queen's Gambit.
Oh yeah, look, I heard
No,
saying on
he's just looking at us.
like,
Okay, so 2 over n, right? The best part is this. The best part is all you gotta do is plug in the width, and so this mi, right? Mi is equal to 2 over n times I. Why is 2 over n times I? Because I is going from 1 to 2 to 3 to 4. Okay? I mean a very important part. Just put it there. Just yeah. Give me one, by the way. That's where I come from. Where I graduated.
You're no longer.
you came from an alligator?
Yeah.
Oh, very smart.
Now think about it. I, right? I is an integer between 1, 2, 3, 4. So basically you're plugging that specific x value into the f of something. That means I'm getting the each particular height of rectangle. So what I'm going to doing is this. We're going to use the definition of integral on this. It's basically limits as n approach infinity. I recorded just in case. Remember, it's going to be f. F of what? F of each width, right? Width is 2 over n times the I. Why is times I? Because I is going to changing from 1 to 2 to 3 to 4 to 5. And remember, I is, this part is going to be,
Can we do summation first?
yeah, we're doing a summation, right? Good job, David.
Thank you.
Summation of I equal to 1, n equal to just n, because n is going to go to approach infinity, times by 2 over n, because times 2 over n. So what I'm going to do is I'm going to plug in this width times I. Why is width times I? I is going to tell you from 0 to 1/2, to 1/2 to 1, from 1 to 3 over 2, from 3 over 2 to 2. So that's what the I is going to changing from 4 in this case, but we want I to be infinite. So what I'm going to do is I'm going to plug in this, and if I plug in this, it's going to be limit n approach infinity of summation.
Wait, so you want n to be infinite or I to be infinite?
I know that.
I is going to infinite.
Yeah.
So it's going to be 2i over n to the square, because I have to plug in 2i over n into the function to get a y value. Once you get a y value, it's going to be 2 over n here. Remember, this is just an x squared, right?
Is that I equals 1 or n equals 1?
N equal to 1. N equal to I equal to 1. You're right. So I equal to 1. So remember that's just x squared. Why is that x squared? I just plug in 2i over n into the square, x squared. Now what's nice thing is this. Limit as n approach infinity of summation of I equal to 1 of n. This one is going to give you 4i squared. Well, 4i squared times 2n, so it'll be 8i squared over n squared. I just distribute everything on the top and bottom. What is constant in this case? 8 and n squared. Remember that can be taken out. So limit n approach infinity of 8 over n squared of summation of I equal to 1 of n, and you got I squared.
Yo, I recognize that. Earlier.
I squared is what? N? According to the equation is what? N times n plus 1? 2n plus 1 over 6, right? Over 6. And remember, this is 8 and n squared when limit n approach infinite. Now this becomes a question you know how to do, because this part is actually the easy part. Is limit n approach infinity. I'm going to distribute the top. On the bottom it's going to be 6n squared. On the top is going to be n squared plus 1, n squared plus n times 2n plus 1. So it'll be n to the square 2, or to the cube, plus n squared, so plus 3n squared. Does that make sense?
Yeah, that seems right.
So it's gonna be plus n.
Well,
Plus
three-
n, right?
3n squared, not minus.
Okay, so plus 3n. So now I will have this on the numerator. Now remember, I got it times 8. So it's going to be 16 n to the 3 plus 24n squared plus 8n. Now remember, if you reach the... Wait, I'm missing an n squared on the bottom.
This would just be infinity.
Yeah, there's something on the bottom here I messed up.
On top. Why would it be infinity?
Cubed on the top and squared on the bottom would give you infinity.
Oh, because this one's NQ. My bad. This one's NQ here. So let me make that adjustment. This is to the 3.
Yeah,
This is
Xavier.
3.
We want a number, not just infinity.
Alright. Infinity's easy though.
So this one is NQ over NQ. So this one's NQ. Now, if I divide it by highest degree of n to the cube, if I divide it by n to the cube on all of them,
You know, then it's just 16 over 6.
it'll be 16 over 6, which is 8 over 3. Guess what? If you do integral between 0 to 2 of x squared dx, it's going to be x cubed over 3 between 2 to 0. It'll be 2 to the 3rd power, which is 8 over 3 minus 0. Now you're going to be like, hey, why do I take so long to do this? Do I need to do this ever? No. But I want you to tell you that this where the math derived from is to break the n to infinite amount of pieces. And that's where the integral come from. My past good student always criticized me, said, Mr. Ye, why you don't teach this to your student? My good student, my best student in the top tier student, competition kids student. And I said, look, if I teach this to Calculus 1 student, they will never get it. And I will take too long to do that, and I cannot cover other topic that's important. But this in calculus 2 is where it matters now. So let's repeat everything. This is the width. This is the value you gotta plug in to find out the height. And the value is I can changing from 1 to infinite. If you change it to infinite, that means I break to infinite amount of pieces. Again, that's what summation come into play. Now, UCF have this question on their final exam. Use definition of integral to figure out integration of x squared between 0 to 2.
They give you the 4 summation things.
They give you a 4 summation, and they ask you to evaluate it. And that was worth 15 points. So if you got that question screwed up, let's say goodbye to A. So that's what I'm saying. In UCF are way harder than AP Calculus. Way harder. I would say in level of difficulty, probably 40% harder than the things. So that's why I'm training you guys in case that just say some of you guys gonna go to engineer school. I know Maria wanna go to Georgia Tech because she'll be the only girl there. You can pick the guys. Monday, Tuesday, Wednesday, Thursday.
Girl, where?
You wanna go Georgia Tech?
And I'm gonna go to the University of Princeton.
I want to go to UCF.
I have low standards.
I'm just kidding, Maria.
No, it's actually really fun. You can put everything.
I'm sure Maria, yeah.
You can everybody. If everybody in here talk to you, they need to buy you dinner.
Yeah. You don't have to pay for anything.
Yes,
Calculus,
I'm sort of getting there, but we're gonna get there.
It doesn't even sound that hard. It just sounds like the same thing, but with another variable.
Yeah.
That doesn't sound that bad.
Well, when I freshman multivariable calculus, I'm like, oh, I already know how to do that. It's X and Y. Two variables. That's not how it is. It's X, Y, and Z.
Well, duh.
So you can. This is your homework, or you can try one here. Just only one question, and this question ended up to be easier, believe it or not. Is f of x equal to x cubed, and you going from 0 to 1. Okay, this is your homework. You can get done right now. It's 4 lines, 5 lines.
The 4 over 4. What, how much do you want to break it? How much?
How many?
Yeah, how many pieces do you want us to break it into?
Infinite amount of pieces. I want to actually find the integral of this
Definition of the integral.
using definition of integral.
Is this the only one?
That's only homework question
I'm so bad, I'll break this.
because my third period didn't understand it, so they're gonna have to watch the video.
Oh, I'm just about to wrap.
The answer is very simple. It's a simple fraction.
5 bits.
1,000 over 27.
So simple.
Still a simple fraction.
That's what I initially got for something, for one of the, for the exponent question, and then I realized I took out, like when I took out 10 over 3, I still left in 10 over 3 instead of 2. For like 20 over 3 or whatever. So I had to do a lot of like long division of like multiplication.
Oh my
It was so bad, and then I corrected it.
Oh, don't do that.
It was just 8. It was just 8, right?
Something times 5. Seeing how much I
I equal 1, am I right, guys?
My brain. Times for the width, it's 1 over n.
Let's see.
Yeah, because it's b minus a, so be 1 minus 0 over n, so 1 over n.
The derivative
Is this right, Xavier?
of the x. We know what the. Oh, just in general?
Yeah.
No. Well, is it 1 over n?
I don't remember.
Equal more. That's what a lot of people think. It's like, no, T and R are not next to each other.
Mr. Xavier.
Mr. A. Xavier.
I was gonna ask
Yeah, you
a
were.
question at the same time.
So this is NQ, by the way. I screw up.
Integral. Let's see.
Wait,
That's m of I.
like even further up. Yeah.
You mean the
Too far.
this?
No.
You need
I
this
just wanted
though.
to copy your work from the previous
The
question.
Jaguars are the best two.
I'll be honest.
This one?
Yeah, that one. What? 2 over n times I. Oh, that's just because the specific question.
Yeah, that's it. Yeah.
Is it? Adventure time. Okay. Oh, we still have 2 periods after that.
Then you show up to the
Have you
Florida
finished
meeting.
setting up the
What's that all
song?
about? I thought you wanted to go to Florida.
I do, but I didn't know what time it was. And
Oh, so you're not technically
Ignore him. Ignore him. We gotta get the problem.
no, this is my feature, Andrew.
No,
What did they say?
this one
Wow,
problem.
you should have been there, man. They have a private lake named Lake Waba.
What important stuff?
Like
did they
Alice,
say?
right?
No, that's not the name.
Can you go back to the question?
Lake
Because I
Wobber.
didn't write it down.
Yeah.
It was just actually cube 0 to 1.
It's a nice, not whole number, no. It's a fraction.
Doesn't really matter.
When as n approaches infinity, am I right, guys?
You're on force.
Yeah.
Did you say that you pulled?
Oh, Splatoon.
Did you say that?
That's not what I'm doing.
I know. They just reminded me of that, you know?
Put it right here.
F of, what's
Yes, sir. Big Gator.
is it always 1 over n times I?
Their football team sucks though. Lost to Kentucky. I can't believe lost to Kentucky.
Okay, Trevor Lawrence is a good play.
Who?
He's making fun of Trevor Lawrence. I just don't know where it went from. I had this. No, I took it out.
Yeah, but this one's I over n, not 2 over n. Because it's 0 to 1, so it'd be 1 over n times I.
Songs are just like a series of random noises.
Yeah.
Because the width times I. It's basically width times I.
Yeah.
So the width is 1 over n. It's gonna be 1 over.
Remember, this one is
The width is what?
this one's height, but I don't remember what the actual
Yeah.
bits were.
What? Is it 1 over n times I?
Yeah, I put 1 over n.
1 over n times I, yeah.
So I got it right. You told me I was stupid and wrong. You said
No, I didn't.
yeah, you did. You said Andrew, you're stupid and wrong.
So is it always 1 over n times I?
Andrew,
I'm joking.
Why is it not?
I know you're joking.
Oh! What is the biggest endpoint?
2.
So that means the width is also 1 over n.
What the?
This is also 1 over n.
It'd be, you do it over n, it would be 1 minus 0, right?
Oh, it's hard.
Oh, yeah, I forgot about that. That's
Did you do the biggest one minus the smallest?
yeah, 1 minus 0 over the number from infinity.
Which is n.
Yeah. That makes sense.
So you gotta plug in I over n.
1 over n.
Over and so.
Oh, and
Yeah,
then
so it'd be I cube over n cube.
Then we realize we have 10
Why
times
is
what we need.
1 over n
Not.
I parentheses squared. Or
So cube. Oh, that was a nice sketch. But like easy.
So eventually it's gonna be 1 over n to the 4th outside. Huh?
You're cheating.
Answer is 1/4
You just take the integral.
because b minus a over n. So in last case is 0 to 2. So it'd be 2 minus 0 over n, so 2 over n. But this one's 0 to 1. This one's 0 to 1. See, it's 0 to 1.
Imagine 1 over. So that I was 2.
Mhm.
So we get rid of that. Hey, 1 over 4.
Here, everybody take one. Yeah, you see that? First put they, to their mind. Oh my, he is weird too. level 16 grand. Why?
See one of those moves?
It's everybody.
Oh,
It's not good.
There it goes.
I kind of like focus and you just.
Literally, baseball players because he doesn't like other people. Like, bro, you can't hate everybody. Like, you're not gonna have any friends. He's like, I hate this person. I hate this person. I hate all of your friends. I hate them all. I'm like, why? You're not in baseball. It's true though. Yeah, I'm coming.
He doesn't have any friend outside of baseball.
Not really, no.
But he knows like every damn baseball. Like he'll bring up someone that like goes like. a
Even
school-
go to a different school.
Yeah, school in Georgia. Oh, I know that kid. Yeah, and you're like, wow. Like, I know them because they're a family friend.
You know, what the
Oh, big cow guy, bro.
Why are you guys here early?
You need to talk with Matt. Help him with Matt.
You help them with math.
We have homework.
Yeah. One question.
Okay.
Did anyone get the one that comes for you?
What?
Anyone get one?
The next video. He didn't want on it, see?
What?
What?
Oh, the question change.
That's great. What's the one question?
Homework? Yeah, using definition of it.
Okay.
I should just do 0 to 3. Let's do 0 to 3. I want to be out. 0 to 3.
I'm just doing 0 to 3. I'm just making videos for like BC on YouTube.
I need help.
About what?
The power. The one that we just, learned. The like, what is it called?
Power roll?
Yeah, I don't understand it.
Okay.
Like, I like it's so easy, but
Two bears.
I don't know. I'm having trouble. It's the low round always one.
Uh-huh.
Okay.
The questions are changing.
Woo! Yeah, baby.
Second guy. You can do whatever you do.
Oh. Where's some for
Any resource is fine. I know
That's right.
Is there anything for exponential functions like 2 to the x? I don't think that they're like fit the power. Could it work that?
It's like whatever.
Yeah, 2 to the x for example.
What do you want?
Like power, was it any way to do that?
From the left.
Yeah. Because I know it doesn't fit the
2x over 2.
just the x.
Use the power up.
2 to the power x? No, we don't have. We don't have that skill.
Okay.
They do.
What about like comic sections, like circles? Is there a way to find that as well?
Yeah, of course. 3 dimensional, that calculate. So that's not something I can teach you. Yeah. Fine. Okay, so
Okay, we went over this during class right here, but I didn't have time to finish it. We didn't have time to like finish it,
Okay.
but
That's 3, right?
I just like
Let's do it with negative 6.
we said it was like 6
Yeah.
because
Slope has equal each other, so it'd be negative 2x equal to negative 6. So x has you can do it in software.
yeah, I was like, okay,
Because you made tension to each other, right?
Mhm.
So y value are the same. They are the same. And plug in 3.
and then
Then you should get k is equal to x.
choose something. Oh,
Or you can limit experience.
I think I I just like.
You can try another question. Here's a homework question. You want to try it?
Yeah.
So that way you know if you did it right. Yeah, I haven't posted on Canvas yet, but it's gonna be. How tall are you?
Me, I'm 4'11".
4'11".
I know.
Are you wish you're taller?
Me,
Or you
no.
like to be
I
short?
kind of like being short.
Really?
Yeah. Thank you.
So you- Huh?
No, we're going to one. Do you have homework?
Yeah, we do.
Are you gonna post it?
I mean, you can take a picture here. It's gonna be. Boom. You're gonna take a picture here and take a picture here.
Which ones?
All the out one.
Also, I have a quick question. For derivatives, right? Definition of derivative. We don't need to do something like more than square root. So we don't need to do a cube root or anything.
Definition of derivative. I mean, I can do.
I mean, we can do it, but we don't have to know it, right?
Oh, cube root. No, cube root is. It's hard to conjugate cube root.
Okay, so I think just the square roots.
Square root. Yeah, but not like square root to the third power. No,
I mean, I'm just saying like it's square root. That's it.
doesn't matter. Everything's gonna be fairly like the question was basically from the notes. I don't know how people still fail if the question's still from the notes. But yeah, and they can be different questions. I don't know what is it.
No, you just asked me up. There will be a question with like 5 root. I mean, it's root.
No.
Root 5. Yeah.
No.
That's thank you. Yeah. 8 divided by.
Oh, you went.
Yeah. And then you just we know what to do this. Comes in phase 0. So just be negative. Do you need help grading?
No, we're grading first period. And second period is easy to grade. First period is the worst. Yeah.
I heard you're left. I feel like that class is harder.
You switch your wrong class. Huh?
Cannot handle this song.
Drama of her or drama of me?
Oh, just not you. Just general.
Yeah, no, this.
Like,
It's a science class.
we still have to talk to each other 24/7 every day.
Ooh.
Hey, I mean, you guys should be taking this serious.
No, it's well, this one, it's like.
I think it's bad for not sitting with them and coming to your class. And I'm just like, guys, I do my math. And it's cold in here. And it's nice in here.
Yeah, hold on a minute.
I don't have to listen to your stupid.
Who is it, your friend?
I'm sorry, that's not.
We're not really friends. We're like, well, like they're friends. Like, you don't know any of them.
Elise?
Yeah, like she'd be interesting now.
Yeah.
She's being interesting now.
That means she's always like, we solve the other people. I don't get it.
You know, it's due.
It's fun.
Oh, God. Oh,
I'm so tired.
no.
I was just like, do you have SAT problems?
Huh?
Can you give me SAT?
That's right.
They are all online. There's 4 different versions online.
Yeah. And
There are 4 versions of free SAT College Board issue tests online. And they are open to public.
I have a book. Can I do it and then bring it? And, I'll do like the math. Right? Like, ask you. Like, what's the best way? And then you just.
I don't know. I personally not a big fan of SAT. Like I hate SAT.
Well,
Like
you
I
don't have a choice though. Like you have. Like, it's
yeah, I just don't like how SAT is becoming.
It's
It's
really
more like
stupid.
word problem now. It's more like passage reading. It's no longer too much math. Like the amount of math is like so ridiculously low.
about 20.5.
20.5? I don't know. Take an integral and see what happened. Take an integral of x cubed.
When you saw that circle button, did you get it right?
Or he could, I think it's like, but he doesn't know the actual answer. So I didn't like it. But he doesn't know.
Oh.
He's brown, supposedly.
Oh, I'm feeling good. What is that?
Supposedly brown. Whitewash brown.
Oh, you haven't taken it yet.
No.
I'm like the third.
Wait, how are the test mystery yet? How are the grades?
Oh no.
I probably didn't do that good.
You didn't finish.
we did.
I did right.
How was the test for you?
Are you okay?
We did it. Oh.
It was easy. I feel
That
like
was no, that's good. That's good.
it's easy. It's easy. Yeah, it was pretty easy.
True.
The first one, never mind. I want to like
Why not, bro?
the first one. I think I did it right, and I'm so sure I did it right.
No, wait.
I just want to see it to know I got it right.
What's you?
What did you get? I got Y. He has to take. He has to make.
No, I didn't switch first two period, but I switched 6 and 7.
So he's gonna have a different problem. I got two. Like you said, very good. I got two equations. No, we did it, but it was a different like. That wasn't four, but I got two equations. If you square root two, if you square root x, it's gonna be plus or minus. So you're gonna be negative two and negative one. And then if you plug in. This is it.
It's on your notes, literally.
Okay, so
Yeah, I got that one.
You're only supposed to have one.
Thought you could square root, right? Plus or minus.
Square root only positive answer.
I know I got the other one right. I know the only one.
then you just
Wait, well, you have to
Where they want you to go.
yeah.
It could be 0 to 3, but it's 4 times. Yep. And then you had to divide each for the, or day 6 times. You just solve 0 to 5. Remember what you were saying?
Yeah.
I'm assuming. So, alright, it doesn't. You gotta be smart to look at a graph and see like that y equals a constant is 0. Well, using the power rule, how would you get there?
Take a derivative. No, you have to. You can use definition for derivative.
But you can't use the power rule on.
It's just 3x squared.
Isn't it just zero?
It's like, you start with
It is 0, but I'm wondering if it's.
You know how?
Power rule is just a shortcut, but you
I have one more question. Yeah.
Power rule does not apply to constant.
Wait, have you guys done?
Constant has a constant multiple. Constant.
It's easy.
Alright.
Yeah.
One last thing.
X squared.
Is there, we like going into like the y and stuff.
What about
like the derivative rule? Is there like an easy way to explain why the power rule works? Or was it just a really nice coincidence?
Why is power rule works?
Yeah.
It's a Pascal triangle.
Wait, power rule based on Pascal's triangle.
I don't know.
That's crazy.
You didn't know that?
Oh, this one?
I'll give you a piece
No,
of
he said that. I didn't got it. I don't know. I was about to.
How are you lying? Dude.
Well, that's so higher. Pascal was 630. You got it like and my contact is not even. They gave you like a number at the bottom.
Pascal triangle is actually super cool if you know about math.
I remember it from Algebra 2. I don't remember the numbers.
You guys want to watch a video about Pascal triangle?
You're right. Easy.
Oh, you can do that.
This is all.
Well, it's not-
Sure. I accept it. I accept it.
now. The laws, so, like,
Yeah, maybe just do that.
And you know that you have to plug in negative.
Yep.
You can't.
So the way, so positive thing, you do the.
Yeah, you actually, when you pick positivity, you have to do the whole thing about like,
The division.
good,
and all that.
you have to actually like solve the
And negativity is plug right.
negativity plug in, and then you get your,
Cool.
you'll be fine.
I didn't know. I don't know. This isn't bad.
So, will we have a test next week this year?
Yeah.
When,
Don't know which day.
will it be on Monday?
No, I don't do test Mondays. That's the worst result we can get. Don't test Mondays. I don't think any teacher does test Mondays.
Be surprised.
I don't do test Mondays. I don't like Mondays. I am not even ready on Monday.
Why? What? You're watching Roger Federer?
Where's Roger Federer?
It says Roger Federer Wimbledon. You're watching that?
No.
It's state favorite.
So
AB?
we have like something like.
Power roll.
Oh, you're like integral.
You just set the slope.
The
You
two
just
most
let it-
big. They're like one by
It's
You're doing derivative. You plug back into this. You really learn both of those. So then you get y minus q equals. Then you plug this into the derivative. Also be negative. You can get this. So. Not bad. Then for normal line, just everything will stay except the slope is. Yeah, and then just like flip this. SAT and negative 1 over. So. Unfortunately.
Which slope?
On. There's only that available. Yeah. That seems impossible. It's hard for you, but you are. Like this. It's possible. Oh, for this. Yeah. It kind of makes sense. Actually, is it this weekend? No.
How are you thinking?
2 weeks. I don't know why.
AP Chem is easy.
Green one, the more burn.
Wait, did you like chemistry?
I major in chemistry.
Did you take AP chemistry in high school? How does it compare to the college? Like my 2 years, right?
I think of one class that's closer to college, like AP Calculus to Calculus,
Oh my god, you got
and chemistry to college chemistry. I think chemistry was the closest. But I will never take AP chemistry in high school, just because if you're good at chemistry, you can get much better job than high school teaching. So therefore, there was no good chemistry teacher that teach you AP chemistry.
No, Mr. Greenwald was bragging that he was in the army or whatever, and he keeps like bragging about how he can do JP Passaic and all these classes, and then he doesn't teach us anything. It's like irritating. He talks the whole class. He was talking about homecoming. He was talking about gossip. He was talking about what else? His wife, his dog. His talk about anything other than the actual subject. Like it's like annoying. It's annoying.
I have no respect of that kind of person. No, I have no respect of him.
Yeah, I'm kind of screwed, but.
What? No, Daniel, do that to yourself. He's
No,
you
you can't. Stop. What do you guys think?
And I heard you say weird things to girls.
I'm being honest. So
I don't know. Veda, is that true?
I heard that. think
I've heard that in the past, not really in art class that much, but like I've heard that yeah, basketball.
Like both Paige and Maria says that.
Do you know who he is? Do you know what he looks like? Oh, apparently his wife is like 20 years younger than him.
Yeah.
And she's like skinny and stuff. And he talks about yeah. Cool. You're good. You're good.
I don't know. It's a weird class. I like it. I don't like all like this just stuff that you can't like get yourself, you know. Like in this class you can kind of figure out what to do, but in this one it's just like kind of rules. Like this is why.
I like biology. Biology is my class. Actually, good.
What are you doing chemistry right now?
It's like
Is it AP?
Alan. No, I'm not AP. He's an AP.
But does he teaches regular too?
He teaches Apex, and then he teaches honors, and then he teaches. What period do you have? Second. This stuff actually happened in the 1100 building. In your in your
What?
I couldn't do. I think later on in the day gets worse. That's why.
You can barely come to my class on time. Oh, don't worry, so am I.
You're insane at basketball, man.
Okay,
Did you play the team?
No, Ron Garage is good. That he's got heart. He's trying to pick up every rebound play against Charlie.
You only have it ready.
And he beat him like twice in a row. And he's on the basketball team. Charlie can't even get one rebound out of him. Even like he shoot a ball, Ron Garage will go for the rebound.
Oh, these guys are by the end of the year, I promise.
I wish I was better at basketball.
Goes on for it.
Yeah.
No, you're pretty good. You have good jump shot.
Oh, wait.
It didn't go in yesterday, so that's why I beat you.
Alright, so look. It's like it's 6 plus. Oh, I'm not gonna write. Yeah, now, I'm gonna ask you this. Oh yeah, look back one step. Look back one step.
Philip told me that he was joining the 7th period for
I like Philip.
yeah. He's in my history
So,
class and he's like
We
the same
substitute
way
for this.
in history. Like he's always at home.
He's a good, intuitive kid. I love how he is.
Isn't that good?
Yeah.
And I just told him, I told everybody in first period, I'd take him over
Are you?
anybody else.
Then you just then you get
It's not. He's just like
I know.
the whole day.
Huh?
And he's the person like ask questions.
He's going on forever. How can you probably have like definite answer?
No, he's good. He's good. I wish hands around.
And then she was asking me, you don't know anything in that class. And I was like, oh, I love it. And I was like, I think people
You just
do
know.
it.
He was like, oh, I am. He was like, Mr. Yang told me that you paid for my AP exam and everything.
There it is, the solution.
He was like, but I haven't took a pre-calc.
I was like, oh, you're not.
Not.
Yeah.
You never take pre-cal, it's fine. Trigonometry is easy to do.
This is so
It's really good.
So isn't this equal that? Then
Sorry?
you square it, square it, and square it.
Yeah, 6 plus that. And then you can substitute back in, which I've never
What do you
done.
substitute?
Substitute for x. You know that.
No.
What are you guys doing?
We were trying to problem.
Which problem?
The like repeating one. That equals x.
Yeah, get ready. I'm gonna beat you guys in basketball. But I can.
What is in your recommended? It's so scattered. You play piano? Are you a noob, Mr.?
No, my son just watched him and learned piano from there.
Wait.
What I did too. No, not the piano properly. I tried to play baseball.
No, but it's here. Pro. Like,
I didn't even post the homework on Canvas. I'm so used to it being in Emoto.
Really?
So you found it.
I literally tried to submit the homework in Emoto. And it was like,
No, you might have to delete it on your own.
what a fail.
I don't know why nobody would buy that program. It's a good program.
What's your
Huh?
Someone should tell me that we have so many tests this week. It's really bad.
I don't think so. To manage that kind of thing, the only thing you had to pay for is server and storage. Huh?
Like you have to keep it working. So it's
Please.
No. Once you give it, you just eat it. Because this makes sense. Chemistry, like, I don't even know what I'm doing. It's like, I don't know what we're doing, so I'm just gonna review like the. Wait, he said he does reviews the day before.
He gives you like stuff. Like,
Is that like the test basically?
Yeah.
Is it literally the test?
well, no, he just gives you ideas. Like Mr. J did yesterday. He said, like, go over horizontal math.
Oh.
He doesn't actually send you.
Yeah, but like, is that?
Wait, did you have Miss Brown last week? Okay, remember how she did?
She gave us the study guide, and then the test the next day was exactly the same as the study guide, with different numbers.
Yeah.
That's what he's gonna do.
No,
He does that.
Like this class.
Can't you just like he likes to talk? You're gonna be fine. Like literally everything you did is on. It's like it's 3 questions. You're gonna be.
Man, I miss that motor already.
Me too. Really good.
Yeah.
Why? Is someone buying the domain or what? Or they're just not?
They're just gonna shut down.
Let's learn more.
Huh?
And Moto vanishes in 2 days. You can do it outside on the map.
Wait, why'd you put that on board?
Huh?
Gator.
Somebody give it to me. Besides, I wonder you have.
Yeah, you can do that. You went to Harvard as well.
I did went to Harvard to fence.
Okay, guys, this is Emoto's message to the world. It has been our honor and privilege to create this community platform that has been loved and used by millions of teachers, students, and parents. This has been especially true.
I want to cry.
When all of us look for connection with this actually is that like when all of us look for connection with our fellow colleagues and classmates. However, after more than a decade of ensuring Emoto can stay a free tool for all, we have found that it is no longer viable for us to maintain the level of service we deserve, and we can take pride in ourselves. As a result, we have made the difficult decision to shut down Emoto.com. The last day you will be able to log into Emoto will be September 22nd. You should log in September 22nd in every single class and leave campus. That'd be so mean to yourself.
That's so sad.
Yeah, it's not that. You should make your own like app. You should.
I'm telling you, I'm just put Instagram, put it on Instagram. People's gonna DM me homework. DM me the homework. Yo, you didn't DM me homework. That'd be funny. Reply and comment.
Oh, you know Max? He got a referral in our class.
What? He said dumbest thing.
You know what he did? So he called the girl dumb, and the teacher asked him to apologize, and he was like, what did he say? He's like, no, and he's like, why do I have to apologize? And then she's like, don't you feel so wrong with what you said? And he's like, I could have said, and then he's like, no, I could have said some worse stuff. And then she said, oh, so you're giving us the PV version? And he said, yes. And the match just had to say, I'm sorry. But he's so rude sometimes.
Which teacher is this?
AP Comp teacher. Like, he was I hate this read too, but that was so
I gotta find an example. I knew my.
How do you survive that class? It was irritating.
Oh, I just knew how to do it, so I didn't really listen to her.
She literally gets
So,
mad at all the kids who
For
try.
this, can you do the definition of the derivative for that one? No, because I was trying that.
No, it's not possible. I won't give you hard. I won't give you something that's.
Okay. I'll say it. I'm just curious, like, which one.
He needs to. It was just my contact class, but I just like,
Oh yeah.
I just like,
Yeah,
like,
Not honest, last year I don't think anybody like this shit in the class.
she doesn't teach
Bro,
it.
how would you compare?
She's mean. She's really so mean. Like she's hard for Indian kids like that. Like, she yells at us. She literally moves us around, and
She doesn't like an Indian kid.
I don't know what the problem is.
That's so funny.
But honestly, I cannot believe he did that. Like he just had to say sorry. He didn't even care. Like you can't say that.
Max is being Max.
Ooh,
Max
for
is,
Lander last year. It was 7:19 and I was running to class.
I don't know if
And then
it's social skills.
she was locking the door, and I grabbed and opened the door, and I snapped her Lander.
and what happened?
We just looked at each other. I just sat down, and we were just all quiet.
Questions.
That's actually funny.
I wanted to.
Hey, Instagram, give me that idea.
Okay, nice early.
Yeah, very good.
I would love to know. We did. How could you? Bro.
One minute remaining.
That's good. You can do it anyway. I'm starting to like wrestling. Like wrestling a lot.
Oh yeah. Oh no.
Oh, okay.
Oh yeah, we have a
So you have to use definition, derivative, and then f of x. It'll take a good song. I don't know if you guys know. Oh, you got two parts. Find f prime of x using definition derivative. B is a find equation of tangent line at x equal to 2. That's the first part. Second question, I want you to find vertical asymptote and horizontal asymptote. So find vertical and horizontal asymptote. Sometimes we might have two horizontal asymptotes. So asymptotes TOTS. So the first one, I'm going to ask you to find f of x is equal to 3e to the x minus 7 over 5 minus 2 e to the x. B, I'm going to say f of x is equal to 3 absolute value of x over 5x minus 2. C, I'm going to ask you f of x equal to square root of 16x squared plus 4x over 3x minus 1. Third question is going to ask you f of x is equal to a good number. 1, or the minus 6x. We got f prime of 2 using only definition of alternative bonus limit h equals 0. This one does not have to use any. You just had to evaluate. There's no restriction what thing you use. Okay. What? 15 minutes. What? So, okay, I'll give you 2 more minutes. You should finish up. How do we get out here? Huh? 24? Got 3 more minutes. The bonus question should only take 5 seconds. Last minute. Okay, so I should never expand that. Oh, actually, it doesn't hurt if you expand the bottom. Yeah, you have to extend it anyway, so. So the first one is negative 2x to the cube. Second one is 3 over negative 2, negative 7 over 5, and natural log of 5 over 2. B is 3 over 5, negative 3 over 5, so hold on, asymptote. 2 over 5 is going to be horizontal. And C is going to be 4 over 3, negative 4 over 3, and 1 over 3 is vertical asymptote. And 3 is 2. Yeah, 10. And last one just 3x.
Yeah.
All right, so what we're gonna talk about today. Do you guys have any question about homeworks? Homework should be pretty easy. Do you guys have any question about homeworks? Yes, Amir.
47 and 39.
$47. What is the question? 47. Okay, I don't know why I don't.